Dear students, welcome to the problem solving session on the transformation W is equal to AZ. Whenever we say W is equal to AZ, we know that W is equal to U plus IV and Z is equal to X plus IY, and here A is any complex constant. So when we multiply A with Z, we can see the pictorial representation W is equal to AZ. And here modulus A is known as scaling factor, and the angle between the positive real axis with W is equal to AZ is known as argument of A or arg A. You can see the image. Since A is a complex number, we can rewrite A as modulus of A into e power I theta. Therefore, when we substitute this A value in W is equal to AZ, we get W is equal to modulus of A into e power I theta into Z. Here, modulus of A is the scaling factor and e power I theta is the rotation. Precisely, let us have a visual understanding. In Z plane, there is a circle with radius lambda. Suppose in W plane, there is a circle with radius phi lambda. It is the scaled circle which is bigger than the circle in the Z plane. And suppose if you have W is equal to e power I theta into Z, now let us take the triangle. It is going to be rotated in some angle, and very important, the shape is preserved. The shape will not change, only it is rotated. The angle is going to be changed here. Therefore, the transformation W is equal to AZ magnifies every figure by modulus of A and rotate it through the angle arg A. We know that the arg A is the angle between the positive real axis and W is equal to AZ in anti-clockwise direction. Now, there are two chances for A. A may be a complex number or A may be a real number, because I can take A as 2 plus 3i, or I can take sometime A as 2 plus 0i. So, if A is real number, then when A greater than 1, only magnification happens. For example, if you take W is equal to 5Z, the image in the W plane is 5 times bigger than the image in the Z plane. Suppose we consider W is equal to 1 by 2 into Z, then the image in the W plane is 50% contracted compared to the image in the Z plane, because we are multiplying the number 1 by 2. So when A lies between 0 to 1, excluding both 0 and 1, reduction or contraction happens, and here also there is no rotation. If A equal to 1, then we get W is equal to Z. Both planes are same, there is no change. And when A is less than 0, we have a scaling factor mod A, and then there is a rotation by 180 degree. Next, when A is a complex number, then if modulus of A is greater than 1, always we see there is a magnification and rotation. And if mod A is equal to 1, it is pure rotation. There is no change in the size. If modulus of A lies between 0 to 1, excluding 0 and 1, we can see contraction plus rotation, and we can see this is the key idea. With these ideas, we are going to solve some problem. Find the image of the circle mod Z is equal to lambda under the transformation W is equal to 5Z. Now it is going to be very obvious, because my A is a real number and it is greater than 1. So simply I will tell only magnification happens. There is no rotation. So let us solve one by one. Step 1, as usual, write W is equal to U plus IV, Z is equal to X plus IY, and the transformation given W is equal to 5Z. Next, step 3, for us the given question is mod Z is equal to lambda. Mod Z is nothing but modulus of X plus IY is equal to lambda, and we know that modulus of A plus IB is square root of A square plus B square. So square root of X square plus Y square is equal to lambda, and finally squaring on both sides, we get X square plus Y square is equal to lambda square. This is nothing but a circle with center 0, 0 and radius lambda. This is in Z plane. Now we have to see how this is going to be transformed in the W plane. For that, let us take the equation x square plus y square is equal to lambda square. Let us go back to step 2. Here we have u is equal to 5x, but I need x. So x equal to u by 5 and y is equal to v by 5. Let us substitute x and y in the equation. Then we get the equation in terms of u and v. U by 5 whole square plus v by 5 whole square is equal to lambda square. So we get u square by 25 plus v square by 25 is equal to lambda square. Simplifying further, we get u square plus v square is equal to 25 lambda square, that is simply pi lambda whole square. Now the center is 0, 0 and the radius is 5 lambda. Now the problem is almost over. We are in the final stage. We have to draw the image of z plane and w plane. Since it is a circle with radius lambda, I can just draw a random circle and mark the equation of circle as mod z is equal to lambda. Under w is equal to 5z, the circle radius is increased 5 times. So we have to draw the bigger circle. So under the transformation w is equal to 5z, my smaller circle mod z is equal to lambda is converted into mod w is equal to 5 lambda. Hope you understand, students. Next we are going to see one more problem. This time I am going to take w is equal to az, where a is a complex number. In this problem, a is a real number, so only magnification happens. In the next problem, a is a complex number. Here a is 1 minus I. So as usual, write the step 1 and step 2. Given w is equal to 1 minus I into z, substituting w and z, we get u plus iv is equal to 1 minus I into x plus iy. Now simplifying further, multiplying 1 with x plus iy, we get x plus iy minus ix minus I square y, and I square is minus 1, so minus into minus we get plus, so x plus iy minus ix plus y. Now we have to segregate the real and imaginary parts from both the sides. We get u is equal to x plus y and v is equal to y minus x. So our u and v are ready. Next, step 3, given y greater than 1, but we found u is equal to x plus y and v is equal to y minus x. So I want y in terms of u and v. So just add this two equation. We get u plus v is equal to 2y. Therefore, y is equal to u plus v by 2. Now substituting this here, u plus v by 2 is greater than 1. U plus v is greater than 2. You can see the typed version. We get u plus v greater than 2 in the w plane. Now how to draw this in w plane? It is very simple. First let us consider u plus v is equal to 2. Now put u equal to 0, we get v equal to 2. Similarly, put v equal to 0, we get u equal to 2 in this equation. That means the line u plus v equal to 2 passes through the points 0, 2 and 2, 0. So easily we can draw the diagram using this points. At first we deal with z plane. We have y greater than 1. For this, first let us draw the line y equal to 1. This is the line y equal to 1 because it is parallel to x-axis. Y greater than 1 means we can see in the xy plane the value above to the line y equal to 1 are always greater than 1. So I can just shade like this. The plane above the line y equal to 1 completely represent the equation y greater than 1. Next, in the w plane, as I said, we have to mark the point 2, 0 and then 0, 2. Now we can draw the line u plus v equal to 2 very easily, but we want to find the image for u plus v greater than 2. It is very easy. If you take any point below the line u plus v equal to 2, suppose you take this point 0, 0, it is not greater than 2. But suppose if you take a point here 2, 2, it is greater than 2. 3, 3, it is greater than 2. It means u plus v greater than 2 is represented like this. So any point above the line u plus v equal to 2 will comes under the category u plus v greater than 2. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.